Today we're going to try to do the transformations all in one graph. So multiple transformations, one graph. And we're going to start with cosine. So again, you need your 5 points for cosine. It starts at its high point at 1, hits the theta axis at 90, low point at 180, back to the theta axis at 270, and high point at 360. So there's your 5 points. Okay, so there is your cosine wave. All right, now we're going to look at the transformations involved here. We have a vertical compression of a half. We have a reflection over the y-axis. We have a horizontal stretch by a factor of 2. We have a horizontal shift 30 degrees to the left, and we have a vertical translation down 2. All right, so what we need to do is to move, I'm going to circle this because this was my start point. We're going to move that point through all the transformations to find out where our start point is. So the vertical compression of a half, reflection, well, a reflection across the y-axis for a cosine graph means absolutely nothing, if you think about it. And I'm just going to jump to this point. If I reflect this point, I get this point. Reflect this point, I get this point. So it's still going to give you the same shape. So technically, the reflection here means absolutely nothing. All right, so anyways, the reflection, we need a stretch, horizontal stretch, which we don't do because it's sitting right on the y-axis, but we do need to go 30 degrees to the left and then 2 units down. Now, 2 units down, we were here, 1, 2. So period length is 720 degrees, and since we've already dealt with the 30 degree to the left and the 2 units down, all we have now to worry about is the amplitude. Now, another thing that I need to do, or I should do, is put in my axis of the curve. This is -2. Okay, just want to make that clear. All right, so 720 degrees is 1 rotation. So that means it takes 360 degrees to go from the high point to the low point. Okay, so 360 degrees would lead you here. Okay, like if this is 30 degrees, left of 0 degrees, then 30 degrees left of 360 is going to be where you want. Now you can count it out if you like, but there should be 12 squares there. Okay, now halfway between high and low, you are going to hit the theta axes. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, sorry. All right, so you can spread this out, and now you can do the left-hand side of the graph. Again, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. All right, so we've spaced it out. I'll draw it in. Okay, so there's your cosine wave. Now, it's a very slight curve because the amplitude is so little. But again, you want to make sure you've got what you need. I've got the equation down here, so we're just going to quickly look at this. We do have an amplitude of a half. Again, the reflection meant nothing. We did stretch it. The period length doubled. It went start point, I forgot to circle, but this was my start point. Went 30 degrees to the left, and we shifted everything down 2 units. Okay, so we also should look at domain and range, and actually we just did this. So domain is theta can be any real number. Range is from -2.5 to -1.5, and I'll write that down for you. Okay, so here's all the information that we were just talking about. the domain, any real number, the range. Again, please write it in this fashion, not two separate entries. You got your amplitude, your period. PS is phase shift. Always put the degrees and the direction. You need both or you will not get full marks. Again, the vertical translation, it's 2 down, so if it went up, you'd say 2 up. Sometimes instead of the vertical translation, they'll ask you for the equation of the axis of the curve. So make sure you're reading carefully because I interchange it at times. Okay, so that graph is done. Let's move on to our next one. All right, this one is a sine graph. So we need the base graph, y equals sine theta. So I've actually put my 5 points on here already, just to make sure you remember. Sine theta starts at 0, 0, high point at 90, goes back to the theta axis, low point at -1, at 270, and then back to the theta axis at 360. So now I'm going to finish the graph. All right, so there's my sine wave. A little bit smoother today. All right, so back here, let's just analyze what we have. We have a reflection in the theta axis. We have a vertical stretch of 2. Oh, we need to do some factoring here. Our K value we know is 3, but our phase shift is not going to be 180 degrees. It's going to actually be 60 degrees to the left, and then you're going to move everything 3 up. So just let me do that factoring for you. Okay, so there it is in factored form, so we can see the correct phase shift, and now we can start moving our graph to find the start point. And again, I forgot to circle the start point. All right, so here it is. I need to see the equation. So we're going to reflect, we're going to stretch 30. Okay, that doesn't deal with the first point. So 60 degrees to the left, 60 degrees to the left and 3 units up. Okay, 60 degrees to the left and 3 units up. So this, oops, I want to do that in a different color. This is going to be our start point. All right, now the other thing we need to look at is period length, and then we just need to worry about period length and then the amplitude here. So let's calculate that for us. Okay, so the period's going to be 120 degrees, and that helps because we know if it's starting here, it only has to go 120 degrees, which is actually 4 squares vertically or 4 lines vertically, to reach the end point. So it starts here, ends here. So that means with the sine wave, again, there's your sine wave, it hits the axis of the curve again right in the middle. It usually hits its high point and then the low point. But with this graph, it's going to hit low first because of the reflection. So, and it has an amplitude of 2. So low point is going to be here, right? 1, 2 units, and then 1, 2 units. High point is going to be at 5. Okay? Now, that gives you one complete wave, and now you can just, you've got a point to put on every vertical line and then draw in your graph. So let's see what that looks like. Okay, so just to give you an idea of what it looks like when you have all your points on, now you're just going to continue to draw in your curve. Okay, but notice that across the theta, the axis of the curve here, it's every 2 vertical lines, it's going to hit the theta axis, right? And then you've got 4 squares between each high and between each low. So I'm going to draw that in. Okay, so there it is. There's your graph. All done.